repeats that pulse is called the pulse repetition rate. So, you know, one radar might do it 1,000 times a second, and the other one might do it 2,000 times a second. It's function of the radar. The lobe itself that is transmitted has a shape to it. Up and down, it's about 25 degrees, 12 up, 12 down. So that as you're rocking in the waves, you never lose the ability to transmit right over the surface of the water. So that's the vertical beam width. Horizontal beam width, we actually want it to be as narrow as possible. And that is directly related to the size of the radar antenna. The little tiny radar antenna has a very wide beam. A very large open array antenna has a very narrow beam. And the horizontal beam width directly translates to resolution of your radar target. So if I'm trying to pick apart two targets like you, and I've got a very wide beam, as I'm coming across, first I pick up the first person, then I pick up both of them, and then I pick up the second person. At no time did I pick up the space in between. If I have a very narrow beam, I can pick up that person, the space in between, and then that person, and I can discriminate them into two targets. So that translates to little tiny 1.5K dome with a 6-degree beam, a couple of kayaks, a couple of miles off your bow. They look like one target. 4-foot open array, you got two targets distinctly shown on there. So that's the real world practice of where horizontal beam width really matters to how many, if you will, dots per inch you get on your radar. The other place it matters is if you're coming in and you're 5 miles out and you see shore and there's a bump on shore. Well, with a dome it looks like a bump, but when you got the big open array with the giant antenna, you can see that that bump is actually a J-hook and there's an entrance to a harbor there. So that becomes a better resolution of a picture that you get with the bigger antenna compared to the smaller one. So size really matters in radar antennas. That's why people buy the big ones. You know, it's because they want resolution. Okay, autopilots. It's the most desirable thing you want for your boat. Once you get wireless remote for your TV, you don't want to get up and change the channels anymore. Once you get autopilot for your boat, you won't have a boat without one, especially if you do any kind of long-range cruising or fishing. Mechanical steering is much more difficult and problematic to put autopilot to. With hydraulic steering, we're just pushing fluid to steer the boat, so it's very easy to get a reversible hydraulic pump and push the fluid to make the rudder go where the autopilot wants. With mechanical steering, you literally have to push that rudder back and forth with some kind of big mechanical device, such as a linear hydraulic unit, or some autopilots actually replace the steering wheel and push the steering from the wheel. So the easiest thing is to just stick with hydraulics on an autopilot, but if you own a boat with mechanical steering, it's a little more difficult, but it still can be autopiloted. When an autopilot works, it looks at the compass and it tries, in auto mode, it's going to try to hold the pointy end of the boat east, say. It just looks at the compass and you're going east, it just says, fine, we're going east. As soon as you get a little bit off course, it goes, oh, we're off course 1 degree to the right. The compass the autopilot's compass senses that. Okay, we're a little bit off course. So the autopilot sends a command to the motor to steer, you know, if you're off course to the starboard, steer to port, and then the rudder moves to port and it brings it back on course. So it's constantly looking at that compass to make sure that you're still going along the way you told it to. And then corrects it using the pump to move the rudder, and then the rudder, there's typically a rudder feedback unit, you've probably seen them on rudder angle indicators, that tells the autopilot what the position of the rudder is. Now, recently they've come out with what's called virtual rudder feedback. That's where the rudder feedback is accomplished by software. And the thing to keep in mind with virtual feedback is that the boat does not know where the rudder is at any given time. It has to sort of guess using the software. And because of that, the moment at which you engage the autopilot and say auto, it's going to assume that you had the boat amidship with the rudders at that point. So it's very important that you do in fact have the boat amidship at that point when you hit auto, that the rudders are amidship, and that way it can go both sides of amidship and work properly. If you've got the rudders over and then you hit auto, it's going to think that's a midship, and it's going to keep going back there to try to get the boat straight, and it'll never get there. So when you're using virtual feedback, not an actual sensor, it's important that you engage auto with the rudders and midship. Boat steerability, you guys all know how well your own boat steers. Some of them steer sweet, some of them are dogs. If your boat doesn't steer well, no autopilot in the world is going to make it steer well. The autopilot at best can steer as well as a sober man. It will not get tired or drunk or distracted, but it will only steer as well as a skilled yachtsman can. You just can't get better than that. So, there's various sensors now that are coming on autopilots. We talked about the compass and the rudder feedback. There's also these what they call rate sensors that have come out, and they sense pitch and yaw. So if you're in seas and your boat's pitching around, the autopilot, on a traditional autopilot, the compass is going, you're going off course to the left, you're off course to the right, you're off course to the left, and the pilot's constantly trying to steer, Now, with the rate sensor, they can go, the boat's just pitching, so we're just going to leave the rudder where it is and let it pitch, and we'll just drive like we drive. We don't try to correct everything when we know we're in following seas and we're doing that. We don't try to overcorrect all the time. So, the autopilot's able to do that once it has a rate sensor. Without a rate sensor, it really can't tell what the pitch and yaw of the boat is, so it has no ability to correct for it. The compasses are black magic. That's the bottom line. I can't fix one, I can't design one, I can't even calibrate one myself. There are guys that can calibrate it. I'm talking about a magnetic compass now, that's a lost art. The compass compensators are all gone. Now we have these electronic compasses, which is a wonderful thing, and the autopilot uses this electronic compass. It still is subject to the magnetic interferences on the boat. So if you got a stereo speaker here and your compass right here, the compass is always going to point south. Period. It's never going to come off of south. So, but the stereo speaker is an extreme example. Macerator pumps, bilge pumps, electric heads, you name it, alternators, engine blocks, there's all kinds of magnetic interferences on boats. And they tell you to put the compass at the center of pitch and yaw and away from magnetic interference. Yeah, in the real world, we can't do that. We'd like to, but we can't.